Hello, my name is Roy Simpson. I'm a professor of mathematics from Cosumnes River College in Sacramento, California. This online lecture is to deal with equations of lines. This will be our first introduction if you're following the lecture series that I have for intermediate algebra courses. This is a first introduction to equations of lines from a very standardized viewpoint. We're going to split this lecture up into 4 videos. This first video will just introduce what's called the slope-intercept form of a line, which in my opinion is the most important form that a line can be given in. And then in the next video, we'll start graphing linear equations given to us in slope-intercept form, and we'll see the power of having an equation given to us in slope-intercept form or writing an equation in slope-intercept form. The third video is more of an auxiliary video. Basically a video that is an optional video. Some instructors like to teach the point slope form of a line. It can be interesting for future concepts, but it's pretty much a useless form of a line, honestly. It's great when you're working with slope, and that's the way you introduce the point slope form of a line, but it's more of a useless form of a line. And I will always say that I would rather know one way to do something correctly than 2 ways to do something correctly. Just because when you're first learning, it's better just to have one way. When you're really good with mathematics, that's when you can start exploring all the different styles of creating lines or whatever it may be. Finally, the last lecture in this series, or this last video for this lecture, I guess, would be determine a linear equation from its graph. So we'll be given a bunch of graphs and we'll just talk about what equations could those graphs represent. So the first example that we're going to attempt here is going ahead and graphing the equation y equals 3/2 x plus 2. We have a bunch of sub questions here. What is the y-intercept? What is the slope? And then these ones that have asterisks on them, they're basically just really sub questions, kind of exploratory questions. If x is increased by 1, what does y change by? And if x is increased by 2, what does y change by? So to graph this equation, the only way we know how to at this point is to create a table of values. But this creating a table of values will soon go by the wayside. We'll be done with this near the end of this lecture. Easy values to plug in are, well, because we have a 3/2 times x, we want to be able to cancel that denominator too. So any multiple of 2, choosing an x value that's a multiple of 2 would be perfect. So like x equals a -2 is fine, because that means that y is equal to 3/2 times, well, a -2, and then plus 2. And now this 2 over 2 turns into 1. That negative times 3 is a -3 plus 2, which is a -1. Following that same line of argument, if I plug in x equals 0, that's the beautiful value for x to plug in, because it makes this entire first term disappear. 3/2 times 0 is just 0. So you plug in x equals 0, you get y equals 2. And then finally, let's plug in x equals 2. If you plug in x equals 2, you get y equals 5. Great. Let's plot these points. I'll use a different color for that. I'll do maybe a red pen here, kind of a large marker. So -2 comma -1 is just about here. 0 comma 2, and then finally 2 comma 5. Oops. All right. So we get this beautiful line. Well, if I were to draw it nicely, it'd be beautiful. And the question is, what is the y-intercept? In other words, where does it hit the y-axis? Well, it hits the y-axis at 0 comma 2. Depends on your instructor. Some instructors are very happy with you answering 0 comma 2 as the point where your line hits the y-axis, or some instructors just are okay with you writing 2 as the answer. I don't care either way. If you're in one of my classes, it's not that big of a deal, because you know what you're talking about no matter what. So notice that the y-intercept is 2 here. Is there a 2 in the original equation? And the answer is yes. There's a 2 right there. It turns out that our y-intercept is represented by that number. that number that's not attached to x. In other words, the constant term. Well, that's pretty interesting. Now let's go ahead and calculate the slope here. The slope is going to be, remember, difference in y values over difference in x values. So let me write that down. The slope is just going to be rise over run, or in other words, change in y over change in x. So let me say that 2 comma 5, which I'll write over here as 2 comma 5 here, and 0 comma 2, those are going to be the points I'm going to consider. Remember, the slope of a line is constant, so it doesn't really matter which 2 points you pick. So my last value, y value, is 5. My first y value is 2, divided by. My last x value is 2. My first x value is 0. Make sure, again, that this y value, this x value are matched up, right? 5 and 2 do occur in the same point. There we are. Same thing with the second one, 2 and 0. All right, 5 minus 2 is 3. 2 minus 0 is 2. So the slope is 3 halves. But something odd, something should be interesting about that as well. The fact is that that number occurs right there. So is it by chance that when we computed the slope, it happened to be the coefficient of x? And is it by chance that when we computed the y-intercept, it happened to be the constant term? And the answer is no, it's not by chance. It actually will always be that way. I'm going to flip the page here, and then I'll just introduce the definition. Actually, it should be called the theorem. So the theorem for the slope-intercept form of a line, and this is one of the most important theorems, or one of the most important forms, I guess, you'll learn in most of intermediate algebra. And you probably already should have learned this anyway, but good enough that we spend some time talking about it. It goes like this. The graph of the equation y equals mx plus b. So somebody just hands you an equation of this form. Y equals 3x plus 10, or y equals 3 halves x plus 2, whatever it may be, is a line having slope m and y-intercept b. And remember, I said I don't mind it when it's written in that form. Maybe your instructor would like it like this. I have no idea. Okay, so when you're given an equation of this form, when you graph it, it will be a line having slope m and y-intercept at b. Along the same lines, if somebody gives you a graph and it's a line, if you can calculate the slope of that line and find the y-intercept of that line, and those are m and b, then you happen to know the equation. So if they didn't give you the equation, but they gave you a graph of the line, you could still find out the equation of the line by finding the intercept and the y-intercept and the slope. Okay? So it's kind of a vice versa thing. This is a very powerful format for the equation of a line. Now going back to our example, I just want to mention the last two items here. If x is increased by 1, what does y change by? And the reason why I'm asking this question is because I think it's good to review every once in a while. If x is increased by 1, so let's say we start at x equals 0 and we go to x equals 1, what does the y value increase by? Well, this is recall the slope addition property that I talked about in a previous lecture. The slope addition property basically says that when you have the graph of a line or an equation of a line, if you increase the x value by 1, the y value changes by the slope. So if I increase the x value by 1 on this line, the y value should change by 3 halves. So that's just kind of a review, but still very important. And then, of course, the second sub-question is, if x is increased by 2, what does y change by? Well, remember, slope is rise over run, so we're saying if we ran forward 2 steps, what does the y value rise by? Well, 1, 2, 3. Okay. So if I run forward 2 steps, so from this point, -2 comma -1, if I ran forward 2 steps, I would have to run back up 1, 2, 3 steps to land back on the line. So if x is increased by 2, y increases by 3. Great. Now I want to kind of show you that this is true in general, that when I give you an equation y equals mx plus b, that the y-intercept is b and that the slope is m. So let's go ahead and show that that is true in general. Now this question I'm asking right now, what is the slope and the y-intercept for y equals mx plus b? I just told you what it was, right? We have a theorem that says, well, the slope is m and the y-intercept is b. Why are you asking me this? The reason why is because in mathematics you have to prove everything that you say. Nothing is true unless it's been proven, essentially is how mathematics works. And so I'm going to introduce you to the idea of a proof here. First of all, there's one thing I know about a y-intercept. At the y-intercept, x is 0. And that's a pretty fast thing to see, because if I graph any linear equation, here's the y-intercept, definitely right there, the x value is 0, the y value is some number. Okay. So to find the y-intercept for this equation, I'll just let x equal 0. If I do that, I get y is equal to m times 0 plus b, or in other words, b. Okay, so when x is 0, y is b, and lo and behold, we have that our y-intercept here is actually b. So the y-intercept is b. That was a very general proof right there. That was us just saying, hey, listen, I don't, this works for anything. B could be any number I want now. So now somebody could say, well, what if b is 10? Then you would say, well, the y-intercept has to be 10. Well, what if b is pi? Well, then the y-intercept has to be pi. Now let's answer the first part of this. What is the slope? Well, to get the slope, you need 2 points, right? So let's make a table of values, x and y's. I already have 1 point, 0, comma b. Another point would be, well, let's just plug in 1 for x. If you plug in 1 for x, you get this business. Y equals m times 1 plus b, or in other words, y equals m plus b. Now, this might look odd to you, but just imagine that m and b are just numbers like 3 and 5, and you get to add those up, they become 8. Unfortunately, we don't know what m and b are, but hopefully we'll still be able to calculate the slope. Remember, slope is equal to rise over run, or in other words, change in vertical value over change in horizontal value. So let's see the vertical values. I'll just do the first y value, this first y value minus the second y value. So in other words, b minus that m plus b. Right? I'm just taking the first y value here and subtracting off this entire second y value. And of course, along the same lines, I have to say then on the bottom, I have to take the first x value and subtract off the second x value. What's interesting about this is that, one, we're going to distribute this negative through here upstairs. So we get b minus m minus b over, and then downstairs, that's just a negative 1. B minus b, that cancels, and you get negative m over a negative 1, or in other words, m. And there we have it, that the slope is m. Without even knowing what m is, this just tells me no matter what m is, that's going to be the slope. So whatever is attached to x is the slope. Whatever is the constant term is the y-intercept. That only is true, by the way, if it's of the form y equals mx plus b. Not 2y, not 3y, not 10y, not pi y, or anything like that. It has to be a single y is equal to mx plus b. So what you've just witnessed, this is essentially a proof of the theorem that we just stated. To illustrate that point that I was mentioning a moment ago regarding the fact that we need y to be by itself on one side, I'm going to just ask really quickly for us to find the slope and the y-intercept of this linear equation. To easily do it, I mean, I could graph this out, but really to easily do this without graphing this would mean just to solve this for y. In other words, to get it in what's called slope-intercept form. So what I'll do is I'll subtract 2x from both sides, and that will get me a negative 3y on the left-hand side by itself. On the right-hand side, I'll have a negative 2x plus 7. You could write it 7 minus 2x, but honestly, I like a decreasing ordered power representation on the right side. So in other words, all variable terms occur before constant terms. So I know that I have a negative 2x, well, that's what I'll have there. And that 7 was positive, so it's plus 7. Then the next step is to divide everything by a negative 3, so I can isolate y here. So y is going to be that negative 2x plus 7 all being divided by a negative 3. And at this point in this course, you should be able to see that that immediately becomes a negative 2x over a negative 3 plus 7 over a negative 3. And remember what I said about, I'm sorry, I'm writing my implications in. Remember what I said about negatives and denominators. It's just bad form. So this can be rewritten. Y equals, well, negative over negative, that's positive. That's just 2/3 x. And then I'm going to pull this negative out front here. So I get a negative 7/3. And without graphing it, I see that the slope, remember we're looking for this form, y equals mx plus b. The slope in this case is 2/3. And the y-intercept is a negative 7/3. It's not just 7/3 because really the y-intercept is, you would take the sign of this as well. So it's a negative 7/3. If this is a positive 7/3 here, then you would take positive 7/3 as your y-intercept. Okay? So that would be the slope and the y-intercept of that linear equation. Without even graphing it, I know that's true.